The discriminant is the name given to the expression that appears under the square root or radical sign in the quadratic formula. The formula for the discriminant is b squared minus 4ac. The discriminant tells you about the nature of the roots of a quadratic equation given that a, b, and c are rational numbers.
When b squared minus 4ac is equal to 0, then the roots are real numbers and are equal. Example, describe the roots of x squared minus 4x plus 4 equals 0. The values of a, b, c in the equation are a, 1, b, negative 4, c, 4. Substitute these values of a, b, and c in the expression b squared 4ac. So, right after substituting, the answers are 16 minus 16, which is equivalent to 0. Since the value of b squared minus 4ac is 0, we can say that the roots of the quadratic equation x squared minus 4x plus 4 equals 0 are real numbers and equal. When b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational numbers but are not equal. Example, determine the roots of x squared plus 7x plus 10 equals 0. In the equation, the values of a, b, and c are 1, 7, and 10 respectively. Use these values to evaluate b squared minus 4ac. After evaluating, you get 49 minus 40, which is the answer of 9. Since the value of b squared minus 4ac is greater than 0 and a perfect square, then the roots of the quadratic equation x squared minus 7x plus 10 equals 0 are rational numbers but are not equal. When b squared minus 4ac is less than 0, then the equation has no real roots. Example, determine the nature of the roots of x squared plus 2x plus 5 equals 0. In the equation, the values of a, b, and c are 1, 2, and 5 respectively. Use these values to evaluate b squared minus 4ac. After evaluating, you get 4 minus 20, which results in negative 16. Since the value of b squared minus 4ac is less than 0, in the quadratic equation x squared plus 2x plus 5 equals 0 has no real roots.
Our next topic would be finding the sum and product of the roots. As you can see, when you try to solve a quadratic equation in the form of ax squared plus b squared plus c, the sum can be expressed as negative b over a and the product can be expressed as c over a. Now let us have an example. Y equals x squared plus 5x plus 6. The sum of the roots, which is expressed in negative b over a, will have an answer of negative 5, while the product of roots, which is expressed in c over a, will have an answer of 6. Now let us have a second example. X squared minus 2x minus 8. Now the sum of the roots, which is equivalent to negative b over 8, is equal to 2. The product of roots, which can be expressed as c over 8, is equivalent to negative 8.